All right, Algebra 2, we are on to our last topic in quadratics, and that is graphing systems of quadratic functions. Okay, now this is a topic that you could do by hand with a graph, but I figure at this point it'll just be easier to show you how to do it all in Desmos. So this will be a quicker one. We'll go through a few examples and then we'll be all set. Okay, so here we go in Desmos.
Alrighty, everybody, we are here. We're going to do some quadratic systems. Okay, so you can see some of these are a combination of quadratic and linear, and then I have a couple of just quadratics here. Okay, so just going over what a system is real quick. A system is a problem that contains two or more equations, okay, that share a common solution, or in this case, could share common solutions, or they might not have any common solutions, okay? So we're just going to talk about what we see on the graph and then how we find the solutions to these, okay? So I'm just going to type in number 1, okay? I'm just going to type in both of these equations exactly how they look. So y equals x squared plus 2x minus 3, okay? And so I see, as expected, this parabola right here, okay? And then if I type in my second equation, y equals 2x plus 1, okay, what I see is a line, a straight line. Again, as expected, this is a y equals mx plus b equation, not a quadratic. It doesn't have that 2 exponent. Okay, so we would expect it to be a straight line. Okay, and what I see, Desmos highlights all these points for me. Okay, and so what might be helpful is if you zoom in. Okay, if you zoom in here, you can see that this black line intersects with my purple parabola here twice. Okay, and Desmos highlights the intersection points for you. Okay. And those are the places where there would be a common solution, right? So mathematically, if I plugged in 2 for x in both of these equations, I would get 5 as an answer. And if I plugged in negative 2 for x, I would get negative 3 as an answer, okay? And the graph is, the intersection points are a way to display that, okay? So the solutions to this one would be 2 comma 5 and negative 2 comma negative 3. Okay, so that's as simple as that. Okay, that's solving these by graphing, is just looking at the graph, seeing where the lines intersect each other. Okay, there are times where it can be different, and we'll see a couple of those. But yeah, for these ones, first few will be pretty easy. Okay, so same idea. We graph number 2. Okay, we type in those two equations. Okay, so number 2 says y equals negative x squared minus 6x minus 6. Okay, there's my first line, my parabola there. And then my second one says y equals 3. Okay, y equals 3. So we see that y equals 3 is a horizontal line going straight side to side. And then my red line here, my parabola, right? So this, if we zoom in a little bit, okay, we look at this. Okay, Desmos is highlighting this point for you right here as 3 comma or negative 3 comma 3. Okay, now again, if we zoom out, we see that obviously this is the only place where this is going to intersect. So again, this would be an example of one that has just one solution, negative 3 comma 3. So that is one solution for that one. Moving on, number 3, if I graph that one, again, typing in the equation exactly how it looks on the paper. So y equals negative, parenthesis, x minus 2 squared plus 5. Okay, again, I see a parabola there in a nice Kelly green. And then negative x plus 1 is my second one. And again, I see two spots where this purple line intersects my curve, 0 comma 1 and 5 comma negative 4. Again, what you want to make sure of sometimes, though, is that because Desmos does highlight the intersection where it crosses through like the x and y axis automatically. So it can help to zoom in just to make sure that, okay, that is definitely where it's intersecting and not just a where it intersects with an axis. Okay, and this does, okay, we made sure. So my two solutions here are 5 comma negative 4 and 0 comma 1. All right, now the last one here. Okay, last one. Last one in this table, and then we got two more after this. Y equals x squared minus 4x plus 2. Okay, again, my parabola there. And then my second one, I got y equals negative 3/4 x minus 1. Okay, now look at this one. Okay, look at this one. My parabola, I can even zoom out a few times. My parabola is going up forever, and it only extends down to right here. Okay, and my red line, again, it's very straight, it's going that way. Okay, so what happens here? And if I zoom in, we see that these guys are very close to intersecting, but they never quite meet up, right? They never meet each other, okay? So that means that because there's no intersection points, there would be no solution to this system. No common solution across the two where they intersect each other. So that happens, and that would be no solution. Okay. Now these were all combinations of, you see it says linear and quadratic system, because one equation was a line and one was a parabola, a quadratic. And so there are times where we see two different quadratic equations, okay, and that happens too. That just means the graph's going to be two parabolas instead of a parabola and a line, okay, but it's the same process, okay, so you just type in y equals x squared minus 3x minus 9 on the first one, okay, again I can zoom out. My second one, y equals negative x squared minus 3x minus 6, okay. Let's see what happens here. All right, so I've got my two parabolas here, and again, sometimes the intersection points are whole numbers like the last ones. Sometimes they're these crazy decimals, and that happens, okay. But again, what we're focusing on, again, these 2 points are really close to each other, so it can help to zoom in, okay. So this first one, negative 1.225, negative 1.225, comma, negative 3.826. Okay, sometimes you'll need to type all three decimal places. Sometimes it'll say round to the nearest tenth or something. So, and then this bottom one here, again, positive 1.225, and then negative 11.174. Okay, so again, decimals for that one. That's okay, that happens. But there are two places where these lines intersect each other. Okay, last one here. Y equals x squared minus 4, and then y equals 3x squared minus 12. Okay, and again, get my zoom the right way. And okay, so we see these parabolas are very similar. Okay, my purple and my black one here. Okay, but we see they do intersect. Okay, and let's zoom in on that just to make sure, right? These intersect negative 2 comma 0 and positive 2 comma 0. Okay, so we see they do intersect each other at those two places right on the axis. Okay, so those would be my two solutions. Okay, 2, 0 and negative 2, 0. Okay, so just again recapping, there needs to be both x and y answers for these. Okay, and there's sometimes can be two solutions, sometimes one solution, sometimes none. Okay, and then sometimes a combination of a line and a curve, sometimes two curves. Okay, but so lots of different possibilities for this, but that's just a little recap of quadratic systems, looking for where the two lines intersect each other for the answers. Okay, thanks for following. Have a good one.